Hi guys, this is the Innovative Minds Tutor. Well, we are on June 2024 preparation, examination grade 12. Yes, this paper was written in Gauteng last year, Gauteng province, last year 2023. That was paper 2 grade 12, right? So without wasting time, if you're new to this channel, what are you waiting for? Kindly subscribe, right? You only subscribe once. So let's start with today's work. In today's work, let's first look at question 1, guys. We will look at question 1. They said A, B, C, D is a quadrilateral on a Cartesian plane with vertices A, -3 and 1, B, 2 and -4, C, 5 and -3, and D, X and 0. There's a missing value there at D, which is X and 0. Right, so the first thing, guys, we are required to calculate the gradient of AC. So let's put that into practice. How many marks? 2 marks. Right, just as we have stated, guys, that's 2 marks. Okay, that was 1.1. So A is given as -3 and 1. Then C is given as 5 and -3. So this is our x1 and this is our x2. This is our y2 and this is our y1. So the gradient of AC is equals to, what is our y2? Our y2 it's -3. Our y1 it's 1. Then our x2 it's 5. 5 minus -3, which is our x1, right? So what is -3 minus -4? -3 minus 1, that will be -4, and negative and negative, that's positive. 5 plus 3, that's 8. So what is 4 all over 8? How many times does 4 goes to 8? So definitely it goes twice. How many times does 8 go to 4? Doesn't go. So in other words, we are left with -half here. So meaning that the gradient of AC is -half, right? So that's the gradient. Okay, so we will look at 1.2 now. At 1.2, guys, we are required to calculate the equation of AC, the equation of AC. So we need to find the equation of AC, right? Because we have a gradient, we will let's take one of the coordinates. Either we take A or we take C, but let's take C so that we are able to find the equation of a straight line. Since the question requires to find the equation of AC, you already have, remember that your equation of a straight line is y is equals to mx plus c. You already have the gradient of AC, which will be -half x plus c. Let's use coordinate A, which is -3 and 1. This is x and y. Where there is y, you're going to put 1, and where there is x, we are going to put -3 plus c there. Here it's the same as having 1. 2 times 1, that will be 2. Then we have -3 times 1, that will be +3. So we have 3 all over 2 plus c, which is 1. So we need to, let's make c the subject of the formula. 1 minus 3 all over 2, what is that? All right, guys, okay, I hope you're doing it correctly. So let's take 1 to the other side. So that will be 1 minus 3 all over 2. So if you're using a mental, we know that this is 1 times 2, which is 2. Then it's the same as having 1 over 1. 1 times 2 is 2. 2 times 1, that will be 2. 1 times 3, that's 3. Then we're going to have -1 all over 2 as our c. Therefore, we are going to have our gradient is -x minus half, right? So that's going to be our equation there. Yes, now let's look at 1.3. At 1.3, we are required to calculate the angle of inclination of AC. Remember, for us to get the angle of inclination of AC, remember that our gradient was given as -half. So let's put that into practice. In this case, the gradient of AC was given as negative half. So we are going to have gradient of AC, which is equals to tan theta. Remember, our aim is to find theta, which is the angle of inclination. Then put negative half at a gradient of AC, then make tan theta the subject. Right? If we put in this, if you plug in tan negative half, you are going to get negative 26, let's punch our calculator. You are going to have negative 26,56. Then that negative 26,56 added by 180, then that gives us theta as 153,43 degrees. So this is our angle of inclination, right, guys? Hope you saw it, guys. So so far so good. Let's go to 1.4. At 1.4, you are required to determine the coordinate of D if AC is perpendicular to the bisector of DB. So we need to we actually need to find this gradient of a bisector BD. Hence we already know the gradient of AC, so that will be easy for us, guys, right? So since they're perpendicular to each other, that means they have a product of -1. They have a product of -1. Let's put that into practice. Yes, guys, when it comes to 1.4, remember, let's go and see what the question requires again. Let's go there and read. At 1.4, they said determine the coordinates of D if AC is perpendicular to the bisector of DB. We already know the gradient of AC, which is -half, but we don't know the gradient of BD. Let's put that into practice. Yes, guys, in this case, you have your gradient of AC multiplied by the gradient of BD. So firstly, we have to find the gradient of BD. Remember, BD. Remember that our B was given as 2 and -4, and our D was X and 0. That was X and 0. So let's calculate this. This is X1, X2, and Y1, Y2. Our Y2 is 0. Our Y1 is -4. Our X2, that will be X, and X1, that will be 2. So 0 and -4, that will be +4, making BD to be 4 all over X minus 2. So remember, since BD is perpendicular to AC, they have a product of -1. So we are going to put -half multiplied by 4 all over X minus 2, which is equals to -1. -1 times 4, that's -4. And 2 times X, that will be 2X. 2 times -2, that's going to be -4, which is equals to -1. So we can multiply everything by 2x minus, we can multiply everything by 2x minus 4. Similarly, this side, 2x minus 4. Okay, let me just give myself a space, a little bit of space there. So this and this, they will automatically cancel each other. We are left with 4 at the left hand side. Then we are left with, remember, this is 4 there. We are left with -1 and 2x minus 4. Then that will be -2x if you multiply by -1, and that will be +4. All right, guys, let's recheck well whether we did well. -1 times 4, that will be -4. 2x times 2, that will be 2x. 2 times -2, that's -4. Then when you multiply everything by 2x minus 4, we are left with 4 here. Don't forget, it's gonna be negative 4 here, right? So it's very good, very useful to go back. Let's take 4 to the other side. This will be negative 4 minus 4, which is negative 8. Then we have negative 2x. Divide everything by negative 2. How many times does 2 goes into 8? It goes 4 times. Therefore, D will be 4 and 0, just as 0 was given there, right? Let's go to our remaining question, which is 1.5 and 1.6. Well, at 1.5, right, they said, hence deduce that ABCD is a kite. For us to prove that ABCD is a kite, that will be simple, guys. We have to calculate the length. Yes, we have to find the length, guys. So we'll have to find the length, guys, that I'm talking about. In this case, take a look at the length of AB and take a look at the length of AD. They are equal, isn't it? Again, take a look at BC and take a look at DC. Their lengths are equal. So we have to prove that, right? So that we can prove that this is a kite. Let's put that into practice. By the look of things, guys, A is given as negative 3 and 1, and B is given as 2 and negative 4. So let's find the gradient of AB. Remember that I told you that take a look at AB and AD. So they have the same gradient. We have to prove that, guys, right? So to make our life easier, so for us to calculate A, we have what? AB. So this is our x1 and this is our x2, right? So let's put that into practice. Remember that this is your x2 minus x1 squared plus y2 minus y1 squared. Okay, you can use any preferable method that you prefer of your choice. So our x2 is 2. 2 minus negative 3 squared, and our y2, that will be negative 4 minus 1 squared. What are we going to have? We're going to have 5 squared plus negative 4 minus 1, that's negative 5. So all in all, that will be 25, and that will be 25, making this to be root 50. AB squared root 50. Right, so when we are here, you need to square root everything. Square root of AB squared is AB, square root of 50, that will be 50. So we are going to have AB as 50. Now let's calculate, let me just do it here side. Let's calculate now the length of AC. Remember that at A, you were given as negative 3 and 1. Let's look at C. At C, we were given as 5 and negative 3. So this is our x1 and this is our x2. So we have AC squared x2 minus x1 plus y2 minus y1 squared. Then okay, let's put that, our x2, that's going to be 5, our x1, that will be negative 3 squared, and our y2, that will be negative 3, y1, that will be negative 1 squared. So let's try and work let's try and work this out. But remember, it is not AC, we are looking at AD. Sorry for that, guys. I'm making a mistake. It's supposed to be AD. Okay, let's just cancel this. Right, it's fine. Let me just do it here. AD. Remember that our A, it's negative 3 and 1, and our D will be 4 and 0, as we have calculated. So to find AD squared, let me just be quick without writing any formula. This is x1, x2, that will be 4 minus negative 3 squared. our y2, that will be 0 minus 1 squared. Then this will be 7 squared. And remember, this is 0 minus 1, which will be 1 squared. So that will be 49 plus 1, that will be root 50, making AD to be root 50. So these are equal, right? They're equal to each other. We are not done, guys. Again, take a look at BC and DC. Those are the two things that we are going to. At first, we look at AB and AD. Now we look at BC and DC, right? Let's put that into practice. At BC, guys, we are still using the distance formula. X1 or X2 there, that will be 5 minus 2 squared plus y2, negative 3 minus negative 4 squared. 5 minus 2, that's 3 squared. Then this is negative 3 minus negative, that's positive 1 squared. Then what are we having? 3 squared is 9 plus 1 squared, that's root 10, making BC to be root 10. Okay, and remember that we also have to look at DC. DC, guys, our D, remember that it's 4 and 0, and our C, it's 5 and negative 3. So it's going to be DC squared, which will be equal to our x2, that will be 5 minus 4 squared, our y2, negative 3 minus 0 squared. Then that will be 1 squared, negative 3 minus 0, that will be negative 3 squared. 1 squared, it's 1, 3 squared is 9, 9 plus 1, that's 10, making DC to be equal to each other. Then thus we could say that two adjacent sides are equal, therefore this is a kite, right? So we have proven that ABCD is a kite. Let's look at our last question. Now we are looking at the area of ABD. So, but first, to find the area of ABD, we need to find